Alrighty, there is not way too much new in this lesson. In lesson 6.7, it's more just solidifying things that we have talked about in the previous lessons. So this first start thinking part says, a company that sells movies online is deciding how much to charge customers to download a new movie. Based on the data from previous sales, the company predicts that if they charge X dollars for each download, then the number of downloads in thousands will be 18 minus X, and they wanted you to fill out this table. So you fill out the table. If it is $3 per download, then you're going to get a bunch of people wanting to buy it because it's super cheap, and that's going to be 15,000 they're guessing at, and that is going to give you a total revenue of $45,000. If they bump it up to $5, less people are going to be able to afford it, so only 13,000 will be able to afford it. But when you multiply those together to find out the total revenue, you do get 65,000, which is more than 45,000. So it's still a better deal, even though they're not getting as many people to buy it. So they keep going up, and they say, well, if we charge $10, then it is going to be about 8,000 because you get the 8 from the 18 minus X. So 18 minus 10 is 8, and that gets you 80,000. Now, when they bump it up to $12, they're getting greedy. Well, not many people or less people are going to be downloading it and paying for that. So it comes out to be only 6,000 people who are going to buy it, and that gets you $72,000. Then you had the 15.3, gets you the 45,000. And then lastly, if you charge all the way up to $18 for this movie, nobody's buying it. So the 0,000 people would buy it, and therefore you make no money. So when you look at this as just an equation, we could say it is X number of dollars per download, and then it is 18 minus X, which would be the number of people who pay for the download. And when you multiply those together to get your revenue, you get X times 18 minus X. Next question says, is the relationship between the price of the movie and the revenue in thousands of dollars quadratic? Explain how you know. So our go-to method of figuring out if something is going to be quadratic is looking at the second difference. The problem here is the second difference rule only works if you are looking at consecutive numbers. So here it goes from 3 to 5 and then from 5 to 10. Those aren't consecutive numbers. So if you look at the second difference, they are not going to be the same. There is actually a way of using like square roots and cube roots to make them the same, depending on how many numbers you're jumping, but it's super confusing. So that's just not a great way to figure out if it's quadratic. In this case, a better way to figure out if it's quadratic is just look at the equation, and you can see that you end up getting x times 18 minus x, and when you distribute, you get 18x minus x squared, and since the highest degree of x is x squared, it's going to be quadratic. That's a different way we could figure out if it's quadratic. Now, the next thing we're doing is we're going to graph these points and try to make sense of the situation. So when we graph these points, I plotted them all here. You could see since it's quadratic, it's going to look like a U, either opening upwards or opening downwards. In this case, it is opening downwards. And once again, the concept here is that the revenue is going up, 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 and then it starts coming down. And the idea is that once you go over and charge too much, less people are actually going to end up buying it. And I actually ran into this issue. Last year, I was helping manage a property in Airbnb, and I was trying to figure out what the appropriate amount that I would set the price for a night's rental. And what I found was when I set it really low, like $99 per night for a full house, a lot of people wanted it, and I wouldn't have many open nights, but I was not making much money because it was priced so cheaply. If I went over and I priced it really high at like $500 a night, I would get barely any bookings. So most of the nights would be open, but those nights that I did go over and get to book were $500 a night. So there was ending up being a sweet spot. For me, it was like $220 was the perfect sweet spot where I would rent the property for that amount. It wouldn't be vacant a crazy amount, but I wouldn't be dropping the price a crazy amount either. So you are looking at this idea of where is that sweet spot. So once we plot all these points, it says, what is that sweet spot? What price would you recommend the company charge for a new movie? Explain your reasoning. So it's kind of hard to tell here, but the vertex is actually going to represent when you're going to have the most revenue. And the vertex on here looks like it's about $9 or $10. And so, as I said, my reasoning is you look at the vertex. What we ended up doing was sticking this in Desmos afterwards. We said x times 18 minus x, and we looked at it, and you were actually able to see the exact vertex, and the exact vertex was at 9,81, which said, hey, charge $9 per movie or per download, and you would get $81,000 in revenue. After that, when you start charging more than $9, the number of people just decreases too much, and the revenue it decreases as well. So this is a real-world example of when you might be looking at quadratics to maximize things. Now, this part right here, we were just talking about how you're using Desmos. You guys have an insane amount of technology at your fingertips. The problem with the technology is you still have to be the human aspect that interprets it and figures out what numbers make sense, what numbers don't make sense, what part of the graph is important, why is it important. Desmos can graph it for you, but you're the one who has to look at it and make sure that it actually makes sense and find out what the meaning is behind the graph. So on here, these are 4 situations we've already discussed. We've also discussed domain, vertex, and zeros, and they wanted to know if you could look at this, figure out what is the domain that makes sense for the problem, what is the vertex and what does it tell you, what are the zeros and what does it tell you, or what do they tell you. So on this first one, we did a problem before where I was talking about a rectangle with a certain perimeter and you're trying to maximize the area. We knew that if you have 25 meters total for perimeter, you only have 12.5 for the length and the width. And for every part that you give to the length, you have to take a little bit away from the width. There's less for the width. So we found out that you could write an equation of x times, and then in this case, it would be 12.5 minus x. They wrote it a little differently in their equation, but it's equivalent. You get the same exact thing. So when you graph this, you have to ask yourself, what is the domain that makes sense for this? Well, the domain, the length in meters where it starts making sense would be 0, though 0 does not make sense. And it goes all the way to 12.5. 12.5 doesn't make sense because that would leave nothing for the width. So it is between 0 and 12.5, and we're able to use interval notation because you can hit any of the values in between. The next one says, what is the vertex? And in this case, it looks like the vertex is about 6.25, 39.063. You can't really see that on the graph. This was in the answer key. That's why I got so specific on here. They must have actually put the equation into Desmos, and it would tell you what the exact vertex is. And the question is, well, how does that help us? That tells you that the side length that would get you the maximum area is 6.25, and that maximum area is going to be 39.063. So that would be the vertex. The vertex is either going to tell you the maximum of something, like this case, or the minimum if the parabola is opening upwards. Now the zeros in this case are at 0 and 12.5, and that could be written as 0, 0 and 12.50. And what is this telling us? It's telling us when the area would be a complete 0. Now the next one is talking about those situations where we had a certain step number and the number of squares that you would have. So the question is, what are the numbers that make sense for the domain? And the numbers that make sense for the domain, the first number would be 0. It doesn't make sense to go into the negatives. It also doesn't make sense to do the decimals. Since we can't talk about decimals, I'm not going to use interval notation. It's just 0, 1, 2, 3, 4, ... meaning it just keeps going on and on and on. So those are the only numbers that make sense. The least number of steps is 0, and the most number is it just goes on forever, but you have to use whole numbers. You're not going to use those decimals. The vertex in this case is 0, 10, and what that means is that at 0, step 0, you already have 10 squares. Okay, so that is going to tell you the least number. Like I told you, the vertex usually tells you the maximum or the minimum. In this case, it's going to tell you the minimum. The minimum number of squares you could possibly have are going to be 10. The next one, what is the 0? In this case, there is no 0. It does not go through the x-axis. And what that means is there is no number of steps that you would have where you would have no boxes, because you could see that you start out with 10 squares. Therefore, you would never have no squares. Let's look at 2 more. On this one right here, this is the distance an object has fallen. We have our equation. The domain starts at 0 and it includes 0. Starts at 0 and includes 0 because you could have 0 seconds. It has not fallen at all. And then in this case, it goes to infinity. I told the students we would change it to say that the cliff was 800 feet high and we were able to have an end to the domain. But the way it's written here, you don't have an end, it just goes to infinity. And you could have decimals as the number of seconds as well. So that's why we can use interval notation. The vertex is 0, 0. That vertex is telling you either a minimum or a maximum. And in this case, it's telling you the minimum. The minimum that it will have fallen is 0 feet with 0 seconds. It's a minimum for that vertex. And the zeros, there's only one 0, it's at 0, 0, and that tells you that at 0 seconds it has dropped 0 feet. Now for this last one, it's talking about the height and feet of an object t seconds after being dropped. The equation is h of t equals 576 minus 16 t squared. That lets me know that the original is going to be at 576 feet high, and then it's dropping and gravity's pulling it down. So on here, what is the domain that makes sense? Well, it starts at 0 seconds, and this one actually has an end. The end is when it hits the ground at 0 feet. So that is at 6 seconds. So it's going from 0 to 6 inclusive. Now the vertex, I was going based off the graph, and I thought it was 0, 580, but it's actually 0, 576. And that is either a minimum or a maximum. And since this is the highest point, it is going to be a maximum. It's saying that at 0 seconds, that's the highest it's ever going to be, and it's at 576 feet high. And then lastly, there are two different zeros here. You have 0, 0, 6 and the 0, 0, negative 6. 0, negative 6 makes no sense for the problem, and 0, 6 means when it hits the ground. So the second 0 that I did not write down just doesn't make sense for the problem because you're not going to have negative seconds. Now, on this one right here, it was a problem just like the first one in the notes. It is going to have an equation in the same concept. As the price goes up, the number of tickets drops, or number of tickets sold drop, but the revenue is going to fluctuate. And once again, it keeps increasing until it gets to a certain point, and then it starts coming back down. So it says, for which ticket price will the theater earn no revenue? $0 for a ticket and $50 for a ticket. Both those times you're going to have no money because you're either giving them away for free or it's so expensive nobody's coming. At what ticket price should the theater sell the tickets if it needs to earn at least $3,200 in revenue to break even, meaning not lose money on the musical? And it's between $10 and $40. Any amount in between those. Now, obviously, we can look at the max, and the max looks like it's probably going to be, my guess is at $25 would get you the max revenue. If you have the 4,800 and then 4,800, I assume midway between there, it's at its highest point. Now, the next one, the function f represents the revenue in dollars the school can expect, and it says if it sells 220 minus 12x coffee mugs for x dollars each, same deal, increasing the dollar price is going to increase revenue, but it's going to do it only for so long, and then it's going to be too expensive that so few people are going to buy it. So we can look at this, and it's asking select all statements that describe this situation. So it's going to be B, the school expects to sell 160 mugs if the price is at $5. You can see you have 5, 160. D, the school will earn about $1,000 if it sells mugs for $10 each. You have 10, 1,000 is on there. And E, the revenue will be more than $700 if the price is between $4 and $14. Now, this next part here says there's a quadratic aspect relating the price of an item to the total revenue. Explain why a higher price the revenue would actually go down. And like I said, the higher the price, less people are going to buy. And at some point, it's not going to make more sense to be selling it for more because so few people are going to be buying it that the revenue actually goes down. Now, in this one right here, gave you a graph. It says, what does the vertex, y-intercept, or zeros help you determine the highest point? And that's going to be your vertex. What is the highest point, and what does when does it reach it? It's going to be at 6.2 seconds, and it's 475 feet. Let's see, that does not make sense. That's at 6.2 seconds. That's not supposed to say 475. That looks much more than that. That looks like it is going to be 600. It's going to be over 600. So let me look at my actual graph. There's no denying that is definitely looking like 475, but it was actually supposed to be 675. I'll go fix my key, but that is at about 6.2 seconds. It's going to be about 675 feet high. Is it the vertex, the zeros, or the y-intercept that help you determine when the rocket hits the ground? That's going to be the zeros. And in this case, there's two zeros. One is negative, which makes no sense for the problem, and the other one is going to be positive. When does the rocket hit the ground? We ignore the 0 that's in the negatives, and it looks like it is going to be about 12.8 seconds would be my guess. What height did the rocket get shot from? What part of the graph indicates this? It's going to be about 50 feet, and that would be your y-intercept. And then what is the appropriate domain for this? I said going from 0 to 12.8 seconds, and I was able to use interval notation because you can have any time in between those. The last one here says, is this going to be quadratic, linear, or exponential? Since the x's are going in consecutive order, 0, 1, 2, 3, 4, I can look at the second difference. The second difference is going to be 8, so that means it is quadratic. And when you divide 8 by 2, that tells you the number in front of the x squared, so it's going to be 4x squared. And I see that when I substitute in the values, either 0, 1, 2, 3, or 4, that does not work, so I still had to add 3 to it. Hopefully that made sense. Sorry about that mistake. That is on, let's see, 4B. Thanks so much for watching.